Okay, so previously we had developed a set of formula for finding the volume and surface area of different prisms. So a rectangular prism, we developed the formula that you can find the volume by length times width times height. The surface area is 2 times length times width times height plus length times height because it's just adding up all the rectangular surfaces, and there's two pairs of each type of surface. And then the space diagonal, which is the from one corner to the opposite in space, is the square root of length squared plus width squared plus height squared. But in general, the more important concept is that the volume of any prism is the area of the base, the bottom or the top, times the distance between the bases, the height of the object, you could say. We also developed these formulas for a cube, which is a prism with all equal sides with a square base, um, where since all the edges are the same, all the side lengths are the same, the volume is just the side length cubed, which is analogous to a square being an area is the side squared. The surface area is 6 times the side squared because of the 6 faces of a cube. And the space diagonal is the side times the square root of 3. With all that information, let's see if we can solve some problems with cubes. So, we're going to consider the cube STUVWXYZ. What is the area of SXYV if SV equals 4? So SV is 4, which means since it's a cube, all the sides are 4. So that is important to know. Now, what is the area of SXYV? Well, let's consider what type of shape that is. So we have SX, which means we want to connect S to X. So I'm going to draw a line connecting them. And then from X to Y, and from Y to V. And since YV is behind the object, if we were thinking three-dimensionally, I'll do a dashed line. So now we have a better picture of what SXYV is. It's this rectangular surface that cuts the cube in half almost, basically. So we want to find the area of, I'll shade it out for us, this rectangular object here. So what do we need to know in order to find that area? Well, we need the dimensions, and it's a rectangular object. So what I could do is off to the side, just draw out separately in its pure two-dimensional form, just like this. And we can label it appropriately SV, and then we would have Y, and then X. Now, SV and XY, we both know have to be 4, since those are the edges of the cube itself. And since all the edges of the cube are the same, they would have to be 4. But now we want to find out what SX is, or VY, because then it should be easy to find the area. Well, notice they are diagonals of the faces on the left and the right, WXTS and ZYUV. So you could even think of drawing those separately. I always find that this helps. Whenever you're looking at the two-dimensional aspect, I think drawing that out separately is an excellent way to solve it. So now let's look at one of the sides. I'll just do WXTS, which we know all the sides are 4. because that's the face of the cube. All these sides here must be the same. What I am interested in finding is Sx, the diagonal. I want to find out what this length is, because that corresponds to the Sx in my other rectangle. Well, we note that this must be a right angle since it's a square, or square. And these two sides are the same, so it's a 45, 45, 90 triangle, which means that the hypotenuse must simply be 4 times the square root of 2, which means Sx is 4 root 2, and therefore so is Vy. So now we can find out the area of S, X, Y, V. That must be equal to the length of the rectangle times the width. So 4 times 4 root 2, which is equal to, well, 4 times 4 is 16, times the square root of 2. And that gives us our answer. So, these problems can look complicated at first. We had this new sort of object within our cube, but if we break it down into simpler problems, two-dimensional ones, that's always the key to solving these problems. Break them down into rectangles, and then if you remember when we worked on rectangles, we always broke them down into right triangles. It's the same thing we're doing before, just more steps. But one thing to note is that this rectangle SXYV is this intersection of a plane and a cube, where the plane passes through the vertices S, X, Y, and V. This intersection, any intersection of a plane and a solid, is called a cross section. So this cross section would be considered a rectangle. And many of our problems that we're going to do in the future rely on taking cross sections, which we will see in just a second.